Okay, we're going to verify identities today. I have already told you guys that you can write these on 3x5 cards, and these are things that we probably already talked about, so make sure that you have got your 3x5 cards and written those things down, and we're going to use them throughout this whole session, so keep them close as you're watching the video. The other thing I want to point out to you is the rules for verifying identities is on page 153. I've kind of outlined this in my own words. These strategies are what I'm going to be using today to teach this. So, having said that, we're going to do our first one. So I have a secant x times cotan x is equal to cosecant x. The first rule that we're going to talk about is, number one, we're just going to work on one side of this equation. My goal here is to make this side exactly like this side. So I'm going to use all those identities over there to make that happen. So this is what I'm going to do. I'm going to rewrite my secant x, but I'm going to change my cotan x to the quotient identity of... Where'd my cotan x go? This is supposed to be cotan right here. There you go. Cotan is cosine over sine. I can also rewrite a secant x as this reciprocal. Secant x is the same thing as 1 over cosine. So I'm going to rewrite that. 1 over cosine x times cosine x over sine x. And at this point, we've already used all the trig we're going to use. At this point, we're using algebra. That one cancels with that. That leaves me with 1 over sine x. Then I'm going to use my reciprocal identities again. 1 over sine x is the same thing as cosecant x. And I have verified this. This side is equal to that side. That is verifying an identity. The next one is I'm going to use factoring. So I have cosine x minus cosine x sine squared x is equal to cosine cubed x. So what I'm going to do is I'm going to factor out. Both of these have a cosine in common, so I'm factoring out cosine x, which is going to leave me with 1 minus sine squared x. Go to your Pythagorean identities. This one, sine squared plus cosine squared is equal to 1. If I subtract cosine squared from both sides, what I'm going to get there is cosine squared x is equal to 1 minus sine squared x, and that's what that is. So I'm going to replace that with cosine x times cosine squared x. Cosine times cosine squared is cosine to the third x, so I have verified that that is the same. One plus sine theta over cosine theta is equal to secant theta plus tan theta. I'm trying to make this side look like that side. So, see, separate a single term into two terms is the strategy I'm going to use here. I'm going to make this 1 over cosine theta plus sine theta over cosine theta, and then I'm going to look at my identities. Keep your identities close so that you can see, well, this 1 over cosine is the same thing as secant theta. Sine theta over cosine theta is the same thing as tan theta, and I'm done. This side looks like that side. That is my goal. Your author actually shows you two methods. This was method 1. Method 2, and it really doesn't matter There's a lot of different ways of getting at the same thing. So the second method is he took that side and put it on the left side and put this over here, 1 over cosine theta plus sine theta over cosine theta. And that would be taking it from here, this 1 plus sine theta over cosine theta, and then breaking it down like this. So you're going to come up with the same thing. 1 over cosine is still, so it's really the same thing. But if you prefer that, that is fine. They're both basically the same. Okay, so what if we had cosine x over 1 plus sine x plus 1 plus sine x over cosine x is equal to 2 secant x. You need to be mindful of looking and seeing what you have. In its simplest form is a fraction added to a fraction, and when you add fractions, you have to have a common denominator, so that's what we're going to do. The common denominator of this thing is going to be 1 plus sine x times cosine x. If I do that, then I'm going to have to multiply cosine x times cosine, which gives me cosine squared x, plus I'm going to multiply this times this, which is going to give me 1 plus sine x times 1 plus sine x. So if you remember doing FOIL, first, outer, inner, last, that's what we need to do with that. Okay, now look what happens. I can do what I'm about to do because it doesn't matter which order I add things. 2 plus 3 is equal to 3 plus 2, so I can rearrange this. So I'm going to make this cosine squared x plus sine squared x plus 1 plus 2 sine x. Go to your identities. What does your identity say that is? Sine squared x plus cosine squared x is equal to 1. So in the place of that, I'm putting 1. So this becomes 1 plus 2 sine x all over 1 plus sine x times cosine x. Now I can just add 1 plus 1 is 2. Actually, yeah, 1 plus 1 is 2 plus 2 sine x all over 1 plus sine x cosine x. I'm probably going to have to that's what I thought. I'm going to factor that back out. It has a 2 in common, so I'm factoring out a 2, which gives me 1 plus sine x all over 1 plus sine x cosine x. Well, that cancels, leaving me with 2 over cosine x. And now you're going to use your reciprocal identities again. 1 over cosine is the same thing as secant. So this becomes 2 secant x, which means I just verified that this side is equal to that side by doing all that manipulation. Okay. Okay, just a refresher. I want this side to look like that side. I always work from the left-hand side, and that's just my preference. You don't have to, that's just what I do. So to simplify this, I'm going to go to my denominator and multiply it by something that's called the conjugate. So let me review with you what a conjugate is. If I have x plus 2 in my denominator, the conjugate is x minus 2. If I have x minus 2, the conjugate is x plus 2. You notice they're the same. The only thing that's changing in this is signs. So what I need to do to this side is multiply by the conjugate. The conjugate of 1 plus cosine is 1 minus cosine. And what that's going to give me is, I'm not going to multiply the top yet together. Let's see what happens in the denominator first. I'm doing FOIL. 1. When I multiply this together and this together, it becomes 0. That's why I'm doing it. That shouldn't have been a square. That should have been 1 minus cosine x. So that's going to give me 1 minus cosine squared x. Because cosine times cosine is cosine squared. So it's 1 times 1 is 1. The middle term becomes 0, because negative cosine plus cosine is 0, and then cosine x times a negative cosine x is going to give me a negative cosine squared x. So now what I'm going to do with this is basically factor that back out. So I put in an extra step. I do that sometimes, so here we go. So I have sine x times 1 minus cosine x. See if that's right. No. This, go to your identities. Go to your identities right here. Sine squared x plus cosine squared is equal to 1. So 1 minus cosine squared x is sine squared x, and that's what I want there. So I'm going to do sine x times 1 minus cosine x all over sine squared. And just like you could cancel an x and an x squared, you can do that with a sine as well. So this sine cancels, that leaves with one sine here. So that ends up being 1 minus cosine x over sine x. And I have verified that. That's what I'm looking for. Okay, I have a tan x minus sine of a negative x, 1 plus cosine x is equal to tan x. I'm sure by now we have discussed this even in odd identities, but let me show you again. When you have a sine negative x, it is an odd function. You don't want to leave this way, so this actually becomes a negative sine x. That's what we're going to do at the top there. So this becomes tan x. This negative makes it come out negative here, so you end up with that, which makes it positive. And what I want it to be is tan x when I get done. So, okay. What we're going to do now is go to your the quotient identities. Tan x is the same thing as sine over cosine. So we're going to use lots of different ones of these things, because what I just did is, where'd it go? This. Try using the following techniques. Write in terms of sine or cosine. That's what we did. We changed tan to sine and cosine. The next step is I need a common denominator, so I'm going to do this one. So my common denominator in my top is going to be cosine. So this becomes sine x plus sine x times cosine x all over cosine x. And then all of that's over 1 plus cosine x. Okay. Since this is a fraction, remember when you divide fractions, you have to invert and multiply. So what that's going to look like is sine x plus sine x times cosine x all over cosine x. And inverting and multiplying is going to give me times 1 over 1 plus cosine x. Just think about it. If I'm dividing by 1 plus cosine x, I'm going to multiply by 1 over 1 plus cosine x. Then what I'm going to do is I'm going to factor. So we're using everything in this one. I'm going to factor out a sine, which gives me 1 plus cosine x all over cosine x times 1 over 1 plus cosine x. So guess what? That cancels, which leaves me sine x over cosine x. Go to your identity. Sine x over cosine x is tan x. So I have verified that this, after I've done all this manipulation, is the same thing as tan x. And that's what I'm doing. I'm verifying that. Okay, I thought I would do some problems out of your homework, so I'm doing the even ones. This is number 2 in your assignment, in your homework section. So what we're going to do with this is leave this cosine, but change this to its reciprocal, which is 1 over sine. And that gives me cosine x over sine x, which guess what? Is cotan. Go to your identities. Cosine over sine is cotan. So I have verified that those are the same. So I have cotan negative x times sine x is equal to negative cosine x. This is your even and odd identities again. So cotan is an odd function, so I'm going to rewrite that as cotan x, a negative cotan x times sine x. I'm trying to verify that this is the same thing as a negative cosine x. So I'm going to rewrite this as a negative cosine over sine times sine over 1. Those cancel. That leaves me with cosine x, and you have verified it. Done. 6. So again, I'm going to use the identities. Cotan, again, is cosine over sine. Secant is 1 over cosine times sine. And look what happens. Everything cancels. And I'm left with 1. So 1 does equal to 1. Cosecant, this is number 8. Cosecant x minus cosecant x cosine squared x is equal to sine x. So I'm going to do cosecant x. I'm factoring it out, which leaves me with 1 minus cosine squared x. Go to your identities. 1 minus cosine squared x is sine squared x. I'm going to rewrite cosecant as 1 over sine. That cancels, leaving me with just a sine x. So I have verified that. Okay, I'm going to my identities. Sine squared x is equal to 1 minus cosine squared x. I did that because my answer's in cosine, so that tells me I need all this side to be cosine. Once I do that, then I'm going to have cosine squared x minus 1 plus cosine squared x, which gives me 2 cosine squared x minus 1, which I have verified that. This is 12. Tan theta plus cotan theta is equal to secant theta cosecant theta. Identities, go to your identities. Sine theta over cosine theta plus cotan is cosine theta over sine theta. Then at that point, remember that that is a fraction. I have to have a common denominator, and that common denominator is going to be cosine times sine, which means I have to multiply that times that, and that times that. And go to your identities. Sine squared theta plus cosine squared theta is 1. And then I'm going to divide this up. 1 over cosine theta times 1 over sine theta. Go to your identities. 1 over cosine is secant. 1 over sine is cosecant. I have verified that. Okay, 15, sine squared theta times 1 plus cotan squared theta is equal to 1. So go to your identities. Sine squared is 1 over cosecant squared. I'm doing that because I have a tan going on here. And 1 plus cotan squared theta, if you go to your identities, is cosecant theta over 1. Those cancel. 1 equals 1. I have verified that. (25) Sine t over cosecant t plus cosine t over secant t is equal to 1. So I'm going to get a common denominator again of cosecant t, secant t, which means I'm multiplying this times this, which is sine t, secant t, plus cosine t, cosecant t. Then I'm going to change this to its reciprocal. So I have sine t times 1 over cosine t plus cosine t times 1 over sine t, all over cosecant t plus secant t. And look what happens here. Sine t over cosine t sine over cosine is tan. So I'm going to have tan t plus cotan t all over cosecant t, secant t. Maybe I shouldn't have done that one. I shouldn't have scratched that. Mistake. I'm going to get a common denominator right here of cosine t sine t, which makes this sine squared t plus cosine squared t all over cosecant t, secant t. Well, I'm going to go to the identities now. Sine squared plus cosine squared is 1. 1 over cosine t, sine t, all over cosecant t, secant t. When I mean, you could do, there's different ways you can go from here, but I'm going to do this 1 over cosine t times 1 over sine t, all over cosecant t, secant t. Well, what's 1 over cosine? Well, it's cosecant. What's 1 over sine? It's secant. And when I divide it by that, guess what I'm going to get? I'm going to get 1, which that's what I'm supposed to get all the way over here. Okay. (27) tan t plus cosine t over 1 plus sine t, and it equals secant t. So I'm going to have sine t over cosine t plus cosine t over 1 plus sine t. I'm going to get a common denominator. So that's going to give me sine t times 1 plus sine t plus cosine squared t. If I go ahead and multiply this out, do you see I'm going to have sine t plus sine squared t plus cosine squared t all over that. And then all I have to do is factor out a sine. No, this gives me 1. That gives me 1. So I have sine t, that gives me sine t plus 1 all over that. And do y'all see that that sine t plus 1 is the same thing as 1 plus sine t, so they cancel? So what I'm left with is 1 over cosine t, which is secant t, and that's what I'm trying to verify. So I'm done.